All right, guys. So this is Miss Murphy again, and I'm back with our 3.6 notes. So this is the formal notes on the activity that we did with completing the square. So I am in your packet on page 30. All right. So again, this is kind of the formal um, notes for completing the square. So we kind of explored what it would look like with algebra tiles. Now we're going to actually look at how that connects to the actual algebraic process. So we kind of already discussed some of this. But remember, the turning point of the parabola, also known as the vertex, is relatively easy to determine if the quadratic function is in vertex form. So just to kind of review what we talked about in 3.5. Given this function, all right, what are the coordinates for the turning point? So remember, the original form is y equals a times x minus h squared plus k, where hk is your vertex. So my turning point are these two numbers. And remember, since the negative is within the original formula, this is actually a positive 3. So my vertex is at 3, 2. Now, the range of the graph, so the y values. First off, if we do a rough sketch of this parabola, our a value is positive because there's nothing there. So that means our graph is going to be opening up. So 3, 2 would be something like right here, and then it'll look something like this. So that means my lowest y value is at 2. My highest would be at positive infinity. And we're going to use a bracket with the 2 because it's definite. Now, you guys should already know that. But now we're going to talk about going from vertex form to standard form, which we talked about yesterday. But now we're going backwards, and that involves the completing the square process. So before we talk about going from standard form, or y equals ax squared plus bx plus c, to vertex form, we're first doing the completing the square process, but we just need to do a quick review. So remember, we did some of this with our practice yesterday. If we write the equivalent trinomials for these, remember x plus 5 squared is the same thing as x plus 5 times x plus 5. Now, I know you guys are fully capable of foiling or box methoding this, but your trinomial will be x squared plus 10x plus 25. Same thing over here. This would be x minus 1 times x minus 1. And you can FOIL that or box method it on your own, but it would be x squared minus 2x plus 1. And then lastly, x plus 4 all squared, same thing as x plus 4 times x plus 4, x squared plus 8x plus 16. Now, what do all three of these trinomials have in common? They are known as perfect square trinomials. Which all that means is that if you're given x plus or minus some a value, which is a number, all squared, that's equal to, if you expand it out, x squared plus or minus, depending on what sign's there, a times x, or 2a times x, plus a squared. All right, so that's how I came up with these three so quickly without actually boiling them out. Because if you look, for example, letter B, all you have to do is find x squared, which is just x squared. Then you do 2 times A times B. So 2 times -1 is -2 times our A value, which is times our x. So that'll be -2x. And then you just square the last number. So -1 squared is +1. Same thing over here. X squared is x squared. 4 times x is 4x times 2 is 8x. And then 4 squared is 16. So, given each trinomial in exercise 2, what is true about the relationship between the b and the c value? So, basically, how the b and the c relate is, if you look, the b is always half of this. Well, not quite. So if you look at this, the B and the C, what is true about that relationship? Well, let's kind of look here. So the B and the C here, let's see, we got 10x and 25. Or just 10 to 25. That's our B, that's our C. Then we got -2 and 1, and 8 and 16. Now, if we look closely, all right, let's say we took these values here. All right. You may think, oh, this one I could divide by 2, this one I could multiply by 2, this one I can't really multiply by anything, get straight to it. But if you think about it, think about what we originally started with. So the 1, the 5, and the 4. And think about the formula over here. So how they connect is that if you do your b value divided by 2, all right, and then square it, that would give you your new number. Let's see if that's true. Well, 10 divided by 2 squared, that's the same thing as 5 squared, which is 25, which is what our C value is. Same thing here, -2 over 2 squared. -2 divided by 2 is -1, so this is -1 squared, which is 1. Then 8 over 2 squared, that's 4 squared, 16. So this right here is the relationship. Now, why is that important? Well, it will come into play when we start learning the algebraic process for completing the square. So keep this in your mind. All right, keep that stuck in your mind for right now. Now, each of the following trinomials is a perfect square. We're going to write it in its factored form. So the easiest way to do that is, since we already know they're all perfect square trinomials, all we got to do is take the square root of the first and last term, keep the sign of the second, and write it in the form of something plus or minus something all squared. Square root of x squared is x. Square root of 100 is 10. Plus, that's all it is. You could have also done a factor tree where, 100 times, if we do a times c on top, b on the bottom, has to add and multiply. So it has to multiply to give us 100, add to give us our b value, which is 20. Well, that would be 10 and 10. So if we wrote that as factors, it'd be x plus 10 times x plus 10, which we still have to rewrite to give us that. So this method is kind of the shortcut. You take the square root of the first and last term, keep the sign of the second term, and then just square that entire factor. And that's it. So if I do this for the letter B, square root, square root, square root of x squared is x, square root of 9 is 3, and I want to keep the second sign, so that's a minus, and then I'm going to square it all. Last one, square root, and keep that sign, so this will be x plus 1 all squared. So this process is also pretty important in the completing the square process, so you got to know how to do that. So either get used to doing your big X and doing it that way, or I highly recommend this method right here. So doing the square root method, because you want to be able to do it fairly quickly. Now we're going to do our completing the square method and convert that standard form to vertex form. All right. So to start this, we start with this equation. So y is equal to x squared minus 4x minus 1. Now, the great thing about equations is we can really manipulate them however we want as long as we keep them balanced. All right. So if we were just given x squared minus 4x, all right, what they want to know is what will we have to add to give us a perfect square trinomial if we factored it? Well, how do you think I'd figure that out? You could use algebra tiles, but if you don't have algebra tiles, this is where exercise 3 comes in handy, because we know that the b value of our trinomial is related to our c value if we divide it by 2 and then square it. So that's how we find it. We would take our b value, divide it by 2, and then square it, and that will give us our new c value. So I'm going to do that. So my b value is negative 4. So I'm going to do negative 4 divided by 2 squared. And that is going to give us negative 2 squared, which is equal to 4. So I would have to add 4 to make it a perfect square trinomial. Because then if I factored it, I would take the square root of both, keep the sign. This would be x minus 2 squared. Now, that was if we excluded this negative 1. All right, so that was just if we were just given the x squared minus 4, which was the first part of our function, but they did not include the negative 1. Now, we're going to talk a little bit about how we can deal with that. So, what we're going to do now is we're going to kind of use part A, what we've learned previously with our squares and everything else, with our algebra tiles and with what we learned in exercise 3, and just put everything together. So, when you are using completing the square method, you start by setting your standard form equal to 0. All right. If you remember back in Math 1, all right, whenever you're solving a quadratic equation, you always want one side equal to 0. Okay. That kind of helps out in both making it into vertex form. It helps out when we get to the solving aspect of this, which is a later unit. But we can always set a quadratic equal to 0 and manipulate. Now, if you recall from our completing the square activity with the algebra tiles, we need to add or subtract something to this negative 1. All right. Now, without algebra tiles, that's pretty hard to do. So what I want to do is get my equation to where I just have what I start with in part A, so the x squared minus 4x. And so to do that, I need to move this current c value to the other side using inverse operations. So I'm going to add this 1 to both sides. That goes away. I get x squared minus 4x. I'm going to leave a big space right here is equal to 1. Now, since we have the same thing that we had when we started in part A, you would do your b over 2 squared to find this value. So this value comes from b over 2 squared. That's how you get your new c value. So we already did that up here, and we got 4. So we're going to add 4. Now remember, equations are like a balanced scale. So if you add something to one side and you want your equation to be balanced, you have to add it to the other. So since we added 4 over here, we got to add 4 on the right side. So this would give us x squared minus 4x plus 4 is equal to 1. Not 1, 5. My bad. Now, since we got a perfect square trinomial, we can now factor it to look like some binomial squared. So remember, you take the square root of the first and last term, keep the sign of the second. So this would be x minus square root of 4 is 2, all squared, is equal to 5. Now, if you recall from our completing the square activity, this looks very, very similar to a vertex form. The only problem is that we don't have our k value yet. But that's okay because we still want one side equal to 0. So to do that, I'm just going to subtract the 5 over. And my vertex form would be x minus 2 squared is equal to negative 5. Oh my gosh, no. X minus 2 squared minus 5 is equal to 0. So y equals x minus 2 squared minus 5 is my vertex form. Now, let's double check our graph to make sure that everything's still okay. So, our vertex given this graph, so this is the graph of x squared minus 4x minus 1. Our vertex should 100% be negative 2, negative 5. Not negative 2, it should be positive 2, negative 5. That's our vertex. Let's see if that's true on the graph. Well, here's positive 2, here's negative 5. Yeah, that is in fact our vertex. Now, just to make sure, I also want to try out my y-intercept. So if I plug in a 0 for this x, 0 minus 2 is negative 2 squared, that's 4. 4 minus 5 is negative 1. So my y-intercept should be at the point 0, negative 1. Well, if I come over here, 0, negative 1, that's also the y-intercept of this graph. So we can conclude that these two are the same. All right. So to kind of formalize what we already said, first things first, and this is only one note to note is that you can only do this if your a value is equal to 1, meaning there's nothing in front of your a value. We will talk about in a second how to do it when your a value is not equal to 1. But you would first move your constant to the y side of the equation. I typically just set it equal to 0 and then move it to the other side just because sometimes the y can confuse you. So you can just rewrite your equation, set it equal to 0, and then move it that way. Then you half the value of b. So you do b over 2. You square it. So b over 2 squared. You balance the equation. So remember, whatever you add, dash subtract to 1, you've got to do to the other. And then we just got to move that constant that we have on the other side back over to look like this. So let's do some examples. All right. Now, these are just solely when the x is equal to 1. All right. So when the x is equal to 1, first things first, just from standard form, I can get some basic information. So does it open up or down? It obviously opens up because the a value is positive. That means we have a minimum. Our y-intercept is our c value, so it is at the point 0, -2. Now, we are going to work it out to convert it to vertex form so I can get my vertex. All right, you can still do -b over 2a, but this way, get into the habit of using vertex form because it will help you in other aspects. So I'm going to first set my equation equal to 0. I am then going to move my constant or my current c value over to the other side by inverse operation. So I'm going to add it. So I get x squared plus 6x, and I'm going to leave myself a space just so I know something got to go in that space, is equal to 2. I'm going to then take my b value, divide it by 2, and square it. So b over 2 is 3. Square it, that'll give you 9. So this will be plus 9. And remember, since we're adding 9 to one side, I got to add it to the other side. So this is x squared plus 6x plus 9 is equal to 11. Factor this. So take the square root of first and last term, keep the sign. This is x plus 3 all squared is equal to 11. And then to finish it up, I'm just going to subtract the 11 back over, set it equal to y. So this will be y is equal to x plus 3 squared minus 11. And that's my function in vertex form. So my vertex is clearly the point -3, -11. All right. Let's try another one. Sorry about that, guys. I had to blow my nose for a second. All right. So let's look at letter C now. So letter C, first things first, does it open up or down? It's still opening up. So our A value is positive, which means we have a minimum. Our y-intercept is given to us by our c value, so that's 0, 27. Now I got to do my work. So I'm going to rewrite my standard form, but set it equal to 0. Subtract my c value over to the other side so I can make room for my perfect square. So this is x squared minus 10x, leave a space, equal to -27. Then I do my -b over 2a, not -b over 2. I do my b over 2 squared. So -10 over 2 squared, that's equal to -5 squared, which is just 25. So I'm going to add 25 to the left to make it a perfect square trinomial, which means I got to add 25 to the right. So I'm left with x squared minus 10x plus 25 is equal to negative 2. Factor it. So take the square root of the first and last, keep the sign of the second. So this is x minus 5 squared is equal to negative 2. And then finally, add the 2 back over, set the whole thing equal to y. So y is equal to x minus 5 squared plus 2. And that's what I got in vertex form. So my vertex would be 5, 2. Now, I'm going to do one more, and then the other 3, I'm going to have you guys try on your own, and that'll also be part of your homework. All right. So I'm going to do letter E. So at my y-intercept, which is at 0, 4, A value is positive, so it's opening up, and it's a minimum. Almost all of these will always be up minimum because we're not dealing with an A value that's anything but equal to 1. So take my function, set it equal to 0, get rid of my current value. So I get rid of my current C value by subtracting it over. I get x squared plus 5x. Leave a space is equal to negative 4. Now, next thing I'm going to do is do my b over 2 squared. Now, an issue that you may notice that we may run into right here, that's a odd number. So we know it won't go evenly into 2. That's okay. We can have a fraction as part of our point. So if I do 5 over 2 all squared, that's the exact same thing as doing 5 squared over 2 squared, which is 25 over 4. So I'm going to add 25 over 4 to both sides. Now, this will give me x squared plus 5x plus 25 over 4. It's equal to, now in the spirit of no calculator, I can convert negative 4 to negative 16 over 4. I just multiplied the top by 4, put it over 4 because negative 16 divided by 4 is negative 4. And I'm going to add 25 over 4. So if I do 25 minus 16, that'll give me 9 over 4. So we're going to leave this as 9/4. Now I need to factor it. So I take the square root of the first and last, keep the sign of the first. Now, if you guys look, because you may be like, oh no, how do I take the square root of 25 over 4? Well, we technically already did because we already squared it. So since we did 5 over 2 squared, well, if we go backwards, the square root of 25 over 4 is what we initially squared to get it, which is 5 over 2. So this would be x plus 5/2 squared is equal to 9/4. Then I would subtract the 9/4 to the other side, set it equal to y, and I got my vertex form. So this would be y is equal to x plus 5/2 squared minus 9/4. So my vertex is at the point 5/2, negative 9/4. Now, could you have done decimals? Yes, but I want this to be kind of calculator inactive. So get into the habit of using your fractions. All right. All right, guys. So I want you guys to try B, D, and F on your own. I will post the keys to it in Canvas so you can check your work. And then your homework for tonight, we'll do page 33 together as a class tomorrow because it's a little bit iffy and I want to actually be there to explain it to you, not just have you guys watch a video. But your homework for tonight will be page 34. And yeah, so it'll be page 34 and 35. All right, because you won't have to do any of the ones where A is greater than 1. All right, but we'll talk about A being greater than 1 tomorrow. So again, your homework for tonight is page 34 and 35 all. All right, guys, I'll see you tomorrow.